Hello, welcome all of you. Assalamu alaikum. Myself Mohammad Mubassir, bearing enrollment number GM3146 and my faculty roll number is 20 GGB417. I am a student of BA Honours Geography, 3rd semester, Department of Geography, Faculty of Arts, Aligarh Muslim University. Today I am going to explain Unit 4 of Statistical Method. Now we will see here that what is statistical methods, measures of dispersion. So first of all, we will study in measures of spread or in measures of dispersion. We will study firstly standard deviation, subtopic under coefficient of variation and variance. Now first of all, we will see that what is measure of spread or dispersion. In statistics, dispersion, also called variability, variable, scatter or spread, is the extent to which a distribution is stretched or squeezed. Dispersion is contrasted with location or central tendency, and together they are most used properties of distributions. Dispersion refers to the spread of values around central tendency. There are following common measure of dispersion: the range, mean deviation, or we call as mean absolute deviation, quartile, decile and percentile, and next is standard deviation, and after that variance or coefficient of variance. Now one by one we will discuss all these in this video. An average can represent a series only as best as single figure can, but it certainly cannot reveal the entire story of any phenomenon under study. Especially it fails to give any idea about the scatter of the values of item of variable in the series around the true values of average. In order to measure this scatter, statistical devices called measures of dispersion are calculated. Now range. Range is the simplest possible measure of dispersion and is defined as the difference between the values of the extreme items of a series. Thus, now we will discuss what is range. So we will discuss it in this. That is the simplest possible measure of dispersion. Now range is equals to highest value of an item in a series minus lowest value of an item in a series. So we will have to subtract it from highest value to lowest value. Now the utility of range is that it gives an idea of the variability very quickly, but the drawbacks is that range is affected very greatly by fluctuations of sampling. Its values is never stable, being based on only two values of the variable. As such, range is mostly used as a rough measure of variability and is not considered as an appropriate measure in serious research studies. Now we will take one example like 15, 20, 21, 20, 36, 15, 25 or 15. The range is simply the highest value minus the lowest value in our example distribution. The high value is 36 and the low is 15. This is the highest value and this is the lowest value. So the range is 36 minus 15, which is called 21. This is 21. So the range is 21. We have calculated what? Range. So the range is 21. Now we will see what is mean deviation here. What is mean deviation? So mean deviation is the average of difference of the values of items from some average of the series. Sometimes such as difference is technically described as deviation. In calculating mean deviation, we ignore the minus sign of deviation while taking their total for obtaining the mean deviation. So mean deviation is thus obtained as under mean deviation from mean delta x bar, or we called as symbol of mean deviation, or this x bar called arithmetic average, is equals to summation under mod xi minus x bar. We called as xi called the ith value of the variable x and the x bar called arithmetic average upon n. If deviations xi minus x bar are obtained from arithmetic average, So mean deviation from median, this is calculated for mean. Now it is seen to be as median. So mean deviation from median, delta m is equals to summation under mod xi minus m. So m stands for, here it is median, it is written as median here, upon n. So we will see that if deviations xi minus mean under mod are obtained from median, and after that it is to be calculated as mod mean deviation. So mean and median we have seen, now we will see mod. So mod is equals to mean deviation from mod, delta z is denoted as mod, summation under mod xi minus z, summation mod upon n. In deviation xi minus z are obtained from mod, where these are the symbols we are seeing in this video, that this symbol called the symbol of mean deviation pronounced as delta, as we have said here. Now xi is equals to ith value of the variable x and n number of items. Here we called it in this is the n number of items here, this is the number of n number of items here, and x bar is equals to arithmetic average and m is equals to median. When mean deviation is divided by the average used in finding out the mean deviation itself, the resulting quantity is described as the coefficient of mean deviation. Now we will see coefficient of mean deviation is a relative measure of dispersion and is comparable to similar measure of other series. So what we will understand, that it is the similar measure of other series. Mean deviation and its coefficient are used in statistical studies for judging the variability and thereby render the study of central tendency of series more precise by throwing light on typicalness of an average. It is a better measure of variability than range, as it takes into consideration the values of all items of a series. Even then, it is not frequently used measure, as it is not amenable to algebraic process. Now what we have seen in this para, that when mean deviation is derived the average used in finding out the mean deviation itself, so it is described as the coefficient of mean deviation. So we will see the next para and the next topic, which is standard deviation here. What is that? Is standard deviation. So first of all we will understand what is standard deviation here. So standard deviation is most widely used measure of dispersion. In which we are using standard deviation? We are using standard deviation in widely for measuring dispersion of a series and is commonly denoted by symbol sigma. This is the symbol of sigma. Standard deviation is defined as the square root of average of squares of deviations when such deviations for the values of individual items in a series are obtained from the arithmetic average. It is worked out as under. Now we will see what is the actual formula of standard deviation. It is written here. Standard deviation in bracket, as we have said earlier, that standard deviation is denoted as symbol sigma. This is sigma. So standard deviation and this is the symbol of that standard deviation called sigma, is equals to root under summation under bracket xi under bracket xi minus x bar square whole square upon n, and here n stands for number of items, as we have said here, number of items. Now we will see standard deviation is used to measure amount of variability. Standard deviation is used to measure what? Is used to measure amount of variability or dispersion around an average. Technically it is measure of volatility. What? Measure of volatility. Dispersion is the difference between the actual and the average value. The larger this dispersion or variability is, the higher is the standard deviation. Now we will see, when we divide the standard deviation by arithmetic average of the series, what I have said, that when we divide standard deviation by arithmetic average of the series, the resulting quantity is known as coefficient or standard deviation, which happens to be relative measures and is often for comparing with similar measure of other series. What I have said, that known as coefficient of standard deviation, which happens in measure of other series. When this coefficient of standard deviation multiplied by 100, the resulting figure is known as coefficient of variation. What we have said, coefficient of variation when it is multiplied by 100. Understand all of you? Sometimes we work out the square of standard deviation known as variance. What we have called variance, which is frequently used in the context of analysis of variation. Now we will see the next para, that the standard deviation along with several related measures like variance, coefficient of variation, etc. It is mostly in research studies and regarded as very satisfactory measure of dispersion. In a series, it is amenable to mathematical manipulation because algebraic signs are not ignored. We will have to not ignore the algebraic sign because it is very manipulating. It is manipulation. It is compulsory, as we call in the other language. In its calculation, as we ignore in the case of mean deviation, it is less affected by fluctuations of samplings. These advantages make standard deviation and its coefficient a very popular measure of scatteredness of series. It is popularly used in the context of estimation and testing of hypotheses. Again, let's take the set of scores 15, 20, 21, 20, 36, 15, 25 and 15. To compute the standard deviation, we first find the distance between each value and the mean. So what we have to see the distance between each value. In each value we have to see the distance. What is the distance between each value and the mean? We know from above that the mean is 20.875. So the difference from the mean are 15 minus 20.875 is equals to minus 5.875. In next also, after 15, what is written here? 20. So 20 minus 20.875 and 25.875 comes from where? It is the mean. It is the mean of this sum. Mean of some set of square. This is the set of square and this is the mean of that set of square. This is the mean of this set of square. This is the mean of this set of square. So we will have to calculate one by one from the given mean of this set of square. Like 15, 20, 21 all of written here and subtracted it from 20.875 all of, and then the calculation will be here, that minus 5.875 minus 0.875 plus 0.125 minus 0.875 15.125 or minus 5.875. We have calculated and see one by one that the answer is coming here. This is the answers of that scores of set. Now we will see in here also we have see that 25 minus 20.875 we got plus 4.125. 15 minus 20.875 is equals to minus 5.875. So we will notice that value that are below the mean have negative discrepancies. What we have negative discrepancies and values above it has positive ones. Next we square each discrepancy. What we have do, we have square each discrepancy. So what we will get in that time, we have to multiply it with the same values, like minus 5.875 into minus 5.875 we got 34.515625, and in the second value we got 0.875 into minus 0.875 is equal to 0.765625. So goes on like that. We have to calculate all these, like minus 5.875 into minus 5.87 got 34.515625. Now we will see this, that now we take these squares and sum them to get the sum of squares. So here written as called sum of squares value. Here the sum is 350.875. Next we divide this sum by number of scores minus 1. Here the result is 350.875 upon 7 is equals to 50.125. So what we have see here, that this value is known as variance. Square of standard deviation also known as variance. What is variance? So variance is called, the value is known as variance or square of standard deviation called variance. What we call variance? Square of standard deviation known as variance. To get the standard deviation, we take the square root of variance. Remember that we squared the deviation earlier. This would be SQRT anything. 50.125 is equals to 7.79901129253. So here n is equals to number called 8th. 1, 2, 3, 4, 5, 6, 7, 8. 8th number, mean 20.875 we have calculated mean. As we have seen in earlier, median is 20, mode is 15, standard deviation is 7.0799, variance is 50.125, range is 21. So we have calculated all these in a series one by one. Now we will see SD for individual series. SD for individual series called standard deviation for individual series. So sigma is equals to root under summation d square upon n. So n is called number of observation, and here we will see SD. SD is what? Standard deviation is equals to root under summation in bracket x minus x dash, and this x dash called x bar also, whole square upon n, number of observation. Like that, see SD for discrete data. This is for individual data series. I am telling you that this is for individual data series, and the next one is discrete data series. Now sigma is equals to root under summation f d square upon n. So here we will see what is f. Here f is called frequency. F is called what? Frequency. And d square upon n, and n is number of observation. So SD standard deviation is equals to root under sigma or summation x minus x bar whole square upon n, number of observations, or x is equals to sigma fx by n. We have also written like that. Now the third one is continuous data series. This is individual, this is for discrete, and this is for continuous data series. So sigma is equals to root under summation fd square upon n. So SD in continuous data series, we have seen that the SD is equals to root under summation x minus x dash whole square upon n, called number of observation. So we have written it in the short that x called summation fm upon n. Now we will see the next part, that is merit of standard deviation. This is called the merit of standard. So we will apply all these formulas. We will apply all these formulas for individual data series. We have applied this one. For discrete data, apply this one. For continuous data series, we have to apply this one. Now the merit of standard deviation. Among all measures of dispersion, standard deviation is considered superior. This is considered as superior because it possesses almost all the requisite characteristics of a good measure of dispersion. It has the following merits. Now we will have to see and calculate the merits of standard deviation. Number one, it is rigidly defined. How it is defined? It is defined as rigidly. Now the second one is it is based on all the observations. Like observation, we have writing the observations, that is based on all the observation of series, and hence it is representative. Hence it is representative. Now see, it is amenable to further algebraic treatment. Now it is least affected by fluctuation of sampling. Now we will see the demerits. What is the demerits of standard deviation? Let's see. It is more affected by extreme items. It cannot be exactly calculated for a distribution with open-ended classes. It is relatively difficult to calculate and understand. So the new topic of R is coefficient. Now we will see coefficient of variation. In coefficient of variation, the CV called coefficient of variation, we will write it in the short CV. It is a simple idea For a distribution, the coefficient of variation is the ratio of standard deviation to the mean. So CV is equals to sigma upon mu. You can estimate the coefficient of variation from a sample by using the ratio of sample standard deviation and the sample mean, usually multiplied by 100 as we are and multiplied in the percentile, so that it is on the percent scale. This ratio is known as relative standard deviation when the data are positive. Now see CV for a population, called coefficient of variation for a population. For what? For population. So coefficient of variation is equals to sigma upon mu into 100%. We have seen that CV is equals to sigma upon mu into 100%. CV for a sample we see here, the CV is equals to S upon X bar. S stands for here sample into 100%, like this, S upon X bar into 100%. Now we will see the advantages of the coefficient of variation. That what is the advantages of coefficient of variation? How we are using that? The principal advantages of the coefficient of variation written in the short as COV is that it is unitless. It has no unit. It is simply a unitless. A COV can be run for any given quantifiable data and otherwise unrelated. COVs called coefficient of variation can be compared to one another in ways that other measure couldn't. In fact, the unitless quality of COV is what separates it from a standard deviation analysis. The standard deviation of two variables can't be compared in any meaningful way. So in any of the meaningful way, it can't be compared to anyone. By comparing the standard deviation and the mean, however, the COV called coefficient of variation makes every dispersion relative and yet independent of the underlying unit. Now we will see the next part, which is the variance. So before variance we complete this topic. As the measure of risk, it is used to measure volatility in prices of stock and other securities. It allows analysts to assess and compare the risk associated with different potential investment. Therefore, it can be used to measure and manage investment risk. Sometimes we have to manage investment risk. So this is called zero disadvantages. This is called what? Zero disadvantages. Now we will see the last topic called the variance. Now we will see that what is variance. The variance of a set of data. If you are seeing a set of data, so in set of data is defined as square of standard deviation and thus given by S2 in the above example, as we have said. When it is necessary to distinguish the standard deviation of a population from the standard deviation of a sample drawn from this population, we often use the symbol S for letter and lowercase in Greek sigma for the former. Thus S2 and sigma square would represent the sample variance, and population variance respectively. Now we will come to see some examples related to standard deviation in individual data series. In which data series? In individual data series, not in discrete. As we have studied earlier in our previous video, that there are two types of data series. One is individual data series and next one is discrete. So we will study here the individual data series. Calculate standard deviation, variance, and coefficient of variance from the following data. Now we will see, we have given one data here, 5, 10, 25, 30 and 50. So we have to see first of all the formula of mean. So mean is equals to summation x upon n, or we call as sigma x upon n. So this is the formula of mean. Now mean, first of all we will calculate all this. We will have to add all this. 5, 10, 25, 30, 50, we got 120. We got what? 120. And all the number of observation is 1, 2, 3, 4, 5. That is 5. So we have to divide it by 5. So it is divisible by 5 into 2, 10. and here is simply 4 times, it should be clear, that is 24. So 24 is what? 24 is mean here. Mean is 24. Now we will arrange one data. Observation written as x. Observation is denoted as x. And d is equals to x minus mean. X minus mean, it means what? Observation minus mean. And d square here. What is here? Here it is written as d square. So we will see here that this is the observation 5, 10, 25, 30, 50. We have written here like this 5, 10, 25, 30, 50. So we will calculate all this. So we got all this data's mean is what? 24. Here we write 24 mean. Now d is equals to x minus mean. So what is x here? X is 5. 5 minus 9. 5 minus what? 5 minus 24. Here we write it like this. 5 minus 24. We got what? Minus 19. So minus 19 is written here. In the same way, we will do 24 minus 10. Sorry, x minus mean. It means 10 minus 24. Like this. This should be like this. 10 minus 24. The answer is minus 14. This is minus 14. Then after 24 minus 25. 24 minus 25. Sorry. It is written here as x minus mean. So x is what? X is 25 minus 24. 25 minus 24, that is plus 1. So what is written here? Now 30 minus 24. So 30 minus 24 is what? This is 6 and in plus. So plus 6. Now 50, it means x. X minus mean. 50 minus 24. So 50 minus 24 is what? 50 minus 24 is 26. So plus 26 it is written here. It is 20 plus 26. Now we will have to square of this sum of d of this deviation. So d square is equals d square. So we will calculate minus 19 into minus 19 like this. Minus 19 into minus 19. What we will get the answer? The answer will be 361. Minus into minus got plus. And 19 into 19, 361 written here. Like this, minus 14 to minus 14, 196 plus 1 into plus 1, 1 plus 6 into plus 6, 36 plus 26 into plus 6, 26. So all the summation into d square is equals to, we have to add all this, we got 1270. So we will find as d, standard deviation is equals to root under d square upon n, number of observation is equals to, what is d square here? D square is 1270. So 1270 upon 5. Why 5? Because number of observation is 5 here. 1, 2, 3, 4, 5 only. So that's why it is written as 1270 upon 5. So if we are calculating 5 into this 1270, we got root under 254, and root 254 so value is 15.937. If you will calculate in your copy or anywhere, you will got this answer. Now we will see variance. So variance is equals to SD square. It means standard deviation square is equals to, what is standard deviation? Standard deviation is 15.937. So we have got standard deviation from here 15.937 and the square, put it here square. So the answer is 254. Now we will find two things. First, standard deviation we find here as d. After that variance we find here variance. After that coefficient of variation. Now we will find CV called coefficient of variance. CV is equals to 100 SD mean is equals to 15.937 this value upon 24. So 24 is what? 24 is mean. Here written SD upon mean into 100. So SD upon mean into 100. It is written as like this. SD 15.937 upon 24 upon mean is 24 into 100. If we will calculate this, so then we will got 16.40%. This is the answer of our actual sum. So we will write here that the mean is what? 24 here, like this 24. V is what? V is variance, and the variance is 254. Now SD is what? SD is standard deviation, 15.937. Here it is SD is here. Now CV, coefficient of variance, it is 66.40%. It is here. So we will calculate this example, this number 1 example, like this. Any problem? Now we will see number 2 next. So in next data we have got one data which is 5, 11, 16, 17, 19, 24 and 30. This is the observation here given to us. This is observation. We have to arrange this. Example number 2. The observation is written here 5, 11, 16, 17, 19, 24 and 30. We will arrange all these observations in ascending order as we have seen here. So the observation is written as X, 5, 11, 16, 17, 19, 24 and 30. So we will calculate all these. We will have to add all these, and we got 17.43 called mean. So mean observation is 17.43. Now we will get D is equals to mean X minus mean, means observation minus mean. So the observation is 17.43 and minus 5. So we will got minus 12.43. After then 11 is X. So X minus mean is 17.3. So 11 minus 16. We have calculated here that 11 minus 17.43. So we will get minus 12.43. Yes, this one minus 12.43. We got here minus 12.43. Then same process, X minus mean means 11 minus 17.43 got minus 6.43. Again 16 minus 17.43 we got minus 1.43. Then 17 minus 17.43 we got 0.43. Then 19 minus 17.43 1.57 we got. Then 24 minus 17.43 we got 6.57. Then the next observation is 30. So 30 minus 17.43, 30 minus 17.43 we got 12.57 here. So this should be calculated from earlier above, that this 12.43, 6.43 minus 1.43 minus 0.43, 1.57, 6.57, 12.57, we got 57.388. This is called what? This is called variance. Sorry. Now we will calculate D square, deviation is square. So we have to multiply minus 12.43 into minus 12.43 into minus 12.43. We have to calculate, or we call that we will multiply with the same number or find square. So minus 12.43 square is 154.47. Here we got. So then also we will square minus 6.43. Minus 6.43 square. We got here 4.33. 41.33. Then also minus 1.43 square. We got 2.04. Minus 0.43 square. We got 0.18. 1.57 square. We got 2.47. 6.57 square. We got 43.18. 12.57 square. We got 158.04. Now finally we have to calculate D square. So summation D square is equals to 401.71. When we calculate all these, we got 401.71. Now when we square all, we got 7.575, which is SD, standard deviation, and the CV is finally 43.47, and CV is calculated as same way how this should be calculated earlier, that SD upon mean into 100, as same SD upon mean into 100. So here SD is what? 7.575 and mean is 17.43 into 100. Finally we got 43.47%. Here is the CV. So mean is 17.43, variance is 57.39, standard deviation is 7.575, and the coefficient of variation is 43.47% as we have calculated here. Now we will see the next example, and we will see the next example of individual data series. So we will see some observation written here, as you will also see that x is equals to x is 10, 20, 30, 40, 50, 60. So the total number of observation is 1, 2, 3, 4, 5, 6, 7. So calculate it and divided by 7. So we have to calculate is 20, 10, 30, 30, 60, 60, 40, 100, 150, 150, 60, 210, 210 and 70, 280, 280 upon 7. 280 upon 7. So we calculate 7, 4, 40. We got here 40. So the mean is 40 here. Now d is equals to x minus mean. X is what? Observation minus mean. So the mean is, so we calculate mean is 40. So x is what? 10. 10 minus 40 is minus 30. 10 minus 40 like this. 10 minus 40 it is minus 30. It is written here minus 30. Then in the next question we see 20 minus, you see 20 minus 40, we got minus 20. The answer is minus. As same we have calculated all this. So 30 minus 40 we got minus 10. 40 minus 40 we got 0. 40 minus 50, 50 minus 40 we got 10. 60 minus 40 we got 20. 70 minus 40 we got 30. So when we will calculate this variance, we will got 400. Total variance calculated at 400. How we calculate this variance? Variance should be calculated as how I said in the previous example. This is variance should be calculated as 400, and then now we will see d square, deviations. So we will calculate minus 30 into minus 30. What we will got? We will got minus minus plus 30 into 30, 900. Fine. Then next one, minus 20 square 400, minus 10 square 100, 0 square 0, 10 square 100, 20 square 400, 30 square 900. So finally we got summation or sigma d square is equals to 2800. When we will calculate all these, we got 2800. Now 2800 is sigma d square. Now as the standard deviation is 20 only, and the CV should be calculated like this. CV should be calculated like SD by mean, SD upon mean into 100%. We will calculate SD. SD is 20 upon mean. Mean is what? Mean is 40 into 100%. We will remove this 0 from this 0. Now 4 is to 5, 20, and 10 into 5, 50. So finally we got 50%. So the CV is what? CV is 50%. Now we will see the next data series called discrete data series. Till now we are solving all these three examples of individual data series. Now we will see one example of discrete data series. That in discrete data series how we will calculate the sum and examples. Now first of all we have observation x 15, 25, 40, 60, 75, and when we calculate all this and divide by sum 2, 4, 5. After calculating all this, divide by 5, we got 40.5 called mean, and after that we got frequency. So frequency is also given as 5, 8, 16, 8, 3. So the sum of frequency is 40. Like when we calculate this, so fx is what? 15 into 5, like this. 15 into 5, that is 75. It is written here fx. So like this, 25 into 8 got 200, 14 into 16, 640, 16 into 8, 480, 75 into 3, 225. Now we will calculate d is equals to x minus mean. We will calculate d here, deviation. Now we will see that d is equals to x minus mean. So where is our d? So we will calculate D here. This is our D called x minus mean. So the x is 15 and the mean is 40.5. So 15 minus 14.5 means mean. Mean is what? 14.5. 15 minus 40.5. We got what? We got minus 25.5. We got minus 25.5. As in the same way we calculate this also, x minus mean. So x is was 25 minus 40.5, 40 minus 40.5, 60 minus 40.5, 75 minus 40.5. We got 34.5 as same. Now we will calculate D square. So finally, which one is D? D is this one. All these are D. Minus 2.2 minus 2.295 minus 0.5 minus 15.5 minus 0.5. These all are D's. So we will square of this number minus 2.5 minus 2.5 into minus 2.5. Sorry, minus 25 into 25.5 minus 25.5 into 25.5. We will got 650.25 as we have seen here. So as same we will square all these. So we got here 240.25, 0.25, calculating 19.5 square is 380.25, 34.5 square is 1190.25. Now finally come to solve FD square. FD, it means what? Frequencies deviation square. That is 3251.25. How this should be calculated? This will be calculated only when frequency into D square. So we have to into 5 and 650 into 2. 5 into 650 into 0.25. Then we will got here 3251.25 here. So simply we calculate which one? F frequency and D square. This 5 into 650.25. Then we will get 3251.25. Fine. As same we calculate this 8 into 240.25. We got 1922. Then 16 into 0.25 we got 4. Then 8 into 380.25 got 3042. Then 3 into 1190.24 we got 3570.75. After calculating these all, summation FD square or sigma FD square is equals to 11790. Now we will calculate mean, SD, variance and CV, all of the four. Now as we all know that mean is equals to sigma fx by sigma f, or called summation fx upon summation f, is equals to, now summation fx is equals to what? See here, summation fx is 16.2520. So 16.20 upon what? Upon sigma f, summation f. So what is summation f here? Now the summation f is 40. Frequency is 40 here. So we will calculate 16, 20, 140. We get what? 40.5. Here is the mean, 40.5. Now we will calculate SD. So SD is equal to root under FD square upon summation F is equals to what? Now what is FD square? So FD square is 11790 here. So 11790 upon sigma F. Sigma F is what? 40. We write here upon 40. If we calculate 11790 root under 11790 upon 40, we got root under 294.75. And root under 294.75 calculated as written here 17.168. So this is called SD. Now we will calculate variance. So variance is equals to SD square is equals to SD is what? We will calculate here SD. SD is what? SD is 17.168. SD is what? SD is 17.168. Here is SD. We don't have any problem. We only understand that where is SD. Here is SD. SD is 17.168. So variance is equals to SD square. SD is what? 17.168 square. And when we doing the square of 17.168, we got 294.75. And after we will calculate CV. So CV is equals to SD upon mean into 100%. So SD is what? Here SD is 17.168 upon mean. Or mean is what? Mean is 40.5. Here is mean. Mean is 40.5. So 17.168 into 14.5 into 100%. When we are calculating all these, we got here 42.39. So finally we will calculate of discrete data series, one example, and we will find mean, standard deviation, variance and CV. Understand all of you students? So thank you. We will meet you in the next video.